Today we're going to work through some long division practice problems, and all of these problems are going to have two-digit divisors. And we'll start off by the first one, which is 1,462 divided by 17. I'll go ahead and tell you that this number, or this problem, will not have a remainder. The way I like to set it up is I like to have a thought bubble number and say, okay, what's 17 really close to that I can use to skip count by, and it is close to 20. And I ask myself, can 17 go into 1? No. So I have to combine these two. I'll say, okay, can 17 go into 14? No. So now I combine these three and I go, okay, can 17 go into 146? It can. And now I got to figure out, well, how many times can it go in there without going over? So I skip count by 20, 20, 40, 60, 80, 100, 120, 140, 160. So I know that it's going to be close to either 7 or 8. I'll try first 17 times 7. 7 times 7 is 49. 7 times 1 is 7 plus 4 is 11, which seems kind of far away. So I'm going to try 17 times 8. 8 times 7 is 56. 8 times 1 is 8. Plus 5 is 3. And 136 is really close, so it can go in there 8 times. 8 times 17 is 136. I need to subtract these two numbers. 6 minus 6 is 0. 4 minus 3 is 1. And I bring down the 2. And I say the same question again. How many times can it go in without going over? I'm going to skip count by 20 because 20 is close to 17. 20, 40, 60, 80, 100, 120. So I'm guessing it's going to be between 5 and 6. So I'm going to try first 17 times. I'll go bigger this time. Just try it out. 17 times 6. 6 times 7 is 42. And 6 times 1 plus 4 is 10. So luckily that one worked out perfectly. It can go in there 6 times. I subtract. I have nothing left. There is nothing at all to bring down. So that means that this is my final answer. Let's try another problem a little bit smaller, but this one's going to have a remainder. Now the unfortunate reality with this one, I can't skip count by 14. The closest thing that I can skip count really well by is 12, because I know my 12's facts, and that's pretty close. And I ask myself, can 14 go into 2? No, it can't. Can 14 go into 29? Yes. If I skip count by 12, 12, 24, 36, 36 is too big. So I'm guessing that 14 times 2 is my best option. And man, that is really close. It can go in there twice. 2 times 14 is 28. I subtract these two numbers, I get 1, and I bring down the 7. How many times can 14 go into 17? It's not going to work out perfectly, unfortunately. It can go in there one time. 1 times 14 is 14. I subtract, and I get a 3. Now, I have nothing else to bring down, so that 3 just can't stay over to it can't be left out completely. So what you have to do, you say, okay, it goes in there perfectly 21 times, but I have a remainder of 3 left over that it won't go into enough, so it won't work out. And this last one is 28 into 2,884. Now I can skip count by 30 with this. If I want, that'd probably be my best option if I need to skip count by anything. But looking here, I can use my 28 for this problem. Can 28 go into 2? No. Can 28 go into 28? Yes. It can go in there one time. 1 times 28 is 28. I subtract these two numbers and I get 0. I bring down my 8. Now the reason I chose this problem is this is a step that a lot of students mess up. If you bring down a number, you have to have an answer in that place value, which becomes problematic because 28 is too big for 8. So if this number is too big for this number, I tell students to use a 0 as your placeholder, and I go through all the steps, the dad, mom, sister, brother steps. I'm dividing, so I say, okay, how many times can 28 go into 8? 0 times. 0 times 28 is 0. 8 minus 0 is 8. Now I bring down the 4, and I have a problem that I can work out because 28 can go into 84. If I bring down a number, I have to have an answer in that place value above it. I'm going to skip count by 30. 30, 60, 90. 90 sounds too big, but it's pretty close. So I'm going to try 28 times 2. I get 56. That seems kind of far away. I'll try 28 times 3. See what I get. 3 times 8 is 24. 3 times 2 is 6, plus 2 is 8. That works out perfectly. So it can go in there 3 times. 3 times 28 is 84. I subtract, I get a 0. I have no remainders, so I am done. And those are just a few long division practice problem that has 2-digit divisors. I'll put up a link for a couple more division videos that can help you out with 2-digit divisors or even 3-digit divisors. Thanks for watching.